Okay. Welcome back to the YouTube channel, guys. Um, like I promised that I'll be giving content after content. So today I had planned to explain a bit of the basics of chemistry. Chemistry is actually a very interesting study. The study of chemistry is very interesting. So to make this so much interesting, I'll start on the basics. So on the basics, it means that I'll talk about the atom, and I'll also talk about the periodic table, right? So for us to be able to understand the whole of chemistry as a whole, it means that we need to understand the basics of chemistry, right? So each and everything on this planet, it is made up of building blocks, right? So everything is made up of building blocks, and those building blocks, we call them atoms, right? So at first I'll explain how an atom is built up like, and then I'll extend this to the next level. I hope you enjoyed this, guys. So let's start. So as I said that we're going to start on atoms, right? So what is an atom? So an atom is a building block of each and everything on the planet. So this is how the atom is made up of. Like I'm trying to explain all the parts of an atom. So an atom is having a nucleus. So this is the nucleus of the atom. So inside the nucleus we have particles inside that are called protons, and we also have particles inside that are called neutrons, right? So they are protons and they are neutrons, which protons are positively charged, right? And the neutrons, they don't have a charge. It means that they're neutral. And protons and neutrons together, when they're added together, so it means that our protons plus our neutrons, when we add them together, we get what we call nucleons. So these added together, they give us what we call nucleons. And nucleons, they give us something that is called the mass number of an atom, right? So protons and neutrons added together, they are called nucleons, and they also give us the mass number of an atom, right? So moving outwards from the nucleus, we have these levels that are sometimes called energy levels. So it depends from atom to atom. Atoms, they have different energy levels depending mostly the period that they're in, right? So I'll explain again when I'm showing you the periodic table. So in this energy levels, we have something that we call the electrons, right? And electrons are negatively charged. So electrons are negatively charged. These electrons are the ones that are responsible for what you call chemical bonding, a topic that I'm mostly interested in, that I'll explain in details after this, right? Shortly after this. So electrons are negatively charged, right? So these particles are negatively charged. So as well, these electrons, number of electrons, so the number of electrons are equals to the number of protons in any atom. So any atom is having the same number of electrons as the same number of protons, right? So this number, again, this is the number that we call atomic number. Atomic number, right? So this is what you call atomic number as well, right? So we said electrons are equal to what? To protons, and we call those atomic number, right? So we call this atomic number. So mind you, don't forget that the periodic table have elements with different atomic number, right? But don't forget that we said electrons also give us the what? The atomic number, and protons and neutrons, they give us what we call nucleons, and which is the mass number, right? Yes. So continuing with this, so I'd like to show you like how atoms or elements are shown on the what? On the periodic table, right? So elements are shown with, for example, let's just take oxygen, right? So oxygen is having a symbol O, right? Capital letter O. So this is the symbol of oxygen, right? So everywhere, anyway, we know that the element with O is oxygen, right? So how is this oxygen built up like? So we also have this on top, which is the atomic number. So this number on top, it is the atomic number, right? It is the atomic number. And I said the atomic number tells us the number of electrons and also the number of protons. So it means that this number is showing us the number of electrons and also number of protons, right? So they show us the number of electrons and the number of protons. And we have this number here that is below, that shows, so this is the mass number of oxygen. So the number here below, it is the mass number. And I explained that the mass number means that the mass number is equals to the number of protons plus the number of neutrons, right? Neutrons, the one that are what? That doesn't have a charge, right? So number of protons plus number of neutrons, they give us the mass number, or rather we can say they give us what you call nucleons, right? So automatically we can say, just because we are seeing that there's 8 protons in this element, so it means that to get the number of neutrons, we can just say 16 minus 8, and you can see that oxygen has 8 neutrons as well, right? So now I will just go in depth to explain about the elements on the periodic table. As I said that chemistry is a interesting subject to do, because like everything that's on the periodic table, it seems more planned. It's more like at the beginning of time, God was like, let me just make this spectacular, like let me just make this awesome, because everything on the periodic table is just so amazing. So I'll explain everything on the periodic table, right? So bear with me. So yes, so this is our periodic table, right? So periodic table have elements in there. So elements, you know that we have metals, we have non-metals, we have semi-metals, and we have noble gases, right? So I'll try to explain and to give you what's going on the periodic table, right? So what's written there on top, they are group numbers, right? So we have group 1 up to group 18, but mostly we just say we have group 1 up to group 8, right? So I'll explain bit by bit what everything is all about. So starting from the period numbers. So as I said, the group numbers, as I said, we have groups from 1 to 8, right? So groups from 1 to 8. And if you check, so it means that our groups are running like this. So this is group 1, this is group 2, this is group 3, and so on in between. And this is group 3, group 4, group 5, group 6, and group 7, and then group 8. So this is our group 8, right? So the group number is, it tells us a lot about an element and interesting facts about that. So I'll get to that. So these are the group numbers. And then from the group numbers, we also have what you call the period. So these are the periods. The periods, they run from left to right, left to right, left to right. So it means that this is period number 1, period number 2, period number 3, period number 4, period number 5, period number 6, and so on, right? So those are periods, and then the groups explain this from top to bottom. So these are our groups from top to bottom. Top to bottom, they are our groups, right? Yes. So what actually happens that makes me say that chemistry is so much interesting? As I said, the periodic number tells us how many electrons are in the element. So hydrogen, there it is having only one electron and also one proton. And you go to helium, there it is having 2 electrons and 2 protons as well. And you go to lithium, 3 electrons, 3 protons, right? So now let me get to explain the importance of groups and also the importance of period, right? Oh, before I go there, like let me just explain. I said, as I said, these are metals, right? So these groups are metals, and then we have semi-metals there, and then we have non-metals. So all these from this side, they are non-metals. They are called non-metals. And we have these ones that are in group 8, which are special gases, which are called noble gases, right? They are called noble gases. So what happens is that all these in group 8, they are not reactive. They don't react because they are what? They are stable. They are stable. And you know that if something is stable, it doesn't need to move. You know that. If something is stable, it doesn't get moved by anything. So it means that it is balanced, right? But all these other metals, all these other elements that are in between here, from this side to group 7, they are unstable. They are unstable. They are so much reactive, right? So for them to be stable, they need to what? To react, right? They need to react so that they can be stable. They need to bond with something else so that they can become stable, right? So that is the whole process of why this chemistry studied about, right? So the ones in group 8, they are stable. I'll explain again why are they stable, right? But the ones in all this in here, they are what? They are not stable, right? They need to what? They need to bond so that they can be stable, right? So the ones in group 7, they are called halides or halogens. These ones in group 7, they are called halides or halogens, right? They are non-metals. Mostly they are gases, right? They're non-metals, and we said those ones, they are noble gases, and these ones, they're what? They are metals. These ones in between, they're transition metals. These ones are alkyl metals, right? And these ones in group 2, they are alkyl earth metals, right? So let me get to explain the groups, the periods, and all that happens, right? So groups, they give us something that is called the valency electrons, right? So they give us what you call the valency electrons. So what are the valency electrons? These electrons are electrons at the outermost shell, at the outermost shell. They're in the outermost shell of an atom. These are electrons in the outermost shell of an atom. Outermost, so we mean that energy level that I talked about. So these are electrons in outer energy level, right? So these are the electrons at the outermost energy level, right? So we're given that by groups, right? So it means that these ones in group 1, they have only 1 electron in the outermost shell. This one in group 2, they're having 2 electrons in the outermost. This one in group 3, they're having 3 electrons in the outermost energy level. Group 4, 4 electrons in the outermost. And then these ones are in group 5, they're having 5 electrons at the outermost. In group 6, they're having 6 electrons at the outermost. And lastly, group 7, they're having 7 electrons at the outermost level. And then this one's in group 8 now. They're having 8 electrons at the outermost, except for helium that is having 2 electrons at the outermost energy level, right? So again, I'll explain how this helps us, right? So before going there, I'll also talk about periods, right? I'll also talk about periods. So periods, what are periods? As I said, periods, they run from left to right, left to right, left to right. So this one is having on is the first period, second period, third period, right? So how does the period helps us with period? They tell us how many shell an atom have. So it tells us how many shells an atom have, right? So it means that hydrogen is only having one energy level, lithium is having two energy levels, sodium is having three energy levels, right? So I'll also explain what are energy levels and how do they come about, right? So having said that, now let me go into deeper details about these periods and these groups and how do we get the bonding, right? So bonding, right? What happens with bonding, right? So what happens, as I explained, I said elements, they need to bond so that they can become stable, except these ones in the group 8, right? So for elements to bond, they follow one of two rules, right? We have the rule that says, that is called the duet rule, and we have another rule that is called the octet rule. So we have the duet rule and we have the what? The octet rule, right? So the duet rule says that for an atom to be stable, or for an element to be stable, it needs to have two electrons in the first energy level. So it needs two electrons in the first energy level. So if it can have two electrons in the first energy level, so it means that now it is balanced. So it means that now it is stable. If you can look at helium, right? Helium is in period 1, so it means that it only has one energy level, right? But as you can see, it is in having two electrons, so it means that that first energy level is filled by two electrons, making it balanced, stable. So it means that it doesn't need to react with anything. So this one doesn't react with anything, right? And then we go to the octet rule, right? So the octet rule says that for an atom to be balanced or to be stable, it needs to have 8 electrons in the outermost shell. So if an atom has 8 electrons in the outermost shell, it means that it can be balanced, right? If it can have 8 electrons in the outermost shell, then it is balanced. Like as it is shown here in neon, argon, and so on, going down there, they are having 8 electrons in the outermost shell, meaning that they are stable, they don't need to react, right? So that is what makes these ones stable. So all other ones, they are not having those properties, so it means that they should what? They should react so that they can get electrons in the outermost shell, right? Okay, so having said that, it means that the ones in group 7, as you see, these ones in group 7, as I explained, that it means that they're having 7 valency electrons, right? So it means that they're having 7 electrons in the outermost shell. So for them to be stable, it means that they need at least they need 1 electron for them to be stable, right? The ones in group 7. And now we go to group 6. Group 6, as I explained, they're having 6 electrons in the outermost shell, right? So if they need they are having 6 electrons in the outermost shell, it means that they need only 2 electrons so that they can be stable. And when you go to these ones in group 5, it means that they need how many? They need only 3 electrons so that they can become stable, because like for them to be stable they need how many? 8 electrons all in all, right? So these ones in group 1 and group 2, they're having 2 electrons in the outermost shell. This one's in group 2, they're having 2 electrons at the outermost shell. This one in group 1, they're having only 1 electron in the outermost shell, right? So if that's the case, that's why we see sometimes metals, they can rather what? They can rather lose the electrons so that they become stable. So it means that if this one loses this 1 electron, it becomes stable again as neon, right? It becomes stable again. If it loses this 1 electron, it can become stable, right? And lithium again, if it loses 1 electron, it can become stable. But these ones in this section, there are the gain electrons, or there are the share electrons with whatsoever that they are reacting with, so that they can become what? Stable. And hydrogen there is the only non-metal that is in group 1, right? So it needs only 1 electron so that it can be stable, right? It needs 1 electron so that it can follow the duet rule, right? So now I'm just gonna take random elements and show the energy levels the way that I was talking about. So in this case, I decided to take 2 elements, which it is the nitrogen and chlorine, right? So if we look at nitrogen, it is having 7 is our periodic number, right? Atomic number is 7. So 7, the number of protons and also the number of electrons in the nitrogen, right? And chlorine is having 17, right? So before we can go in any further, we can try to describe this before I show you what I want to show you, right? Or rather, let me just first show you what I'm trying to show you, and then you have a look at yourself and see what's really going on with these elements on the periodic table, right? So when you're filling the energy levels, this is what happens. So let's start with nitrogen. So nitrogen is having 7 electrons all in all. 7 electrons all in all, right? So what happens is that this nitrogen, or all the elements, they first fill the 1s orbital, right? So that first shell is called the 1s orbital, right? So what we do is that the first energy level is filled by 2 electrons, right? So it means that from 7 electrons, we're going to take 2 electrons. It means that 1 and 2, they filled up the first energy level, right? And we move to the second energy level, which is called the 2s, which is also filled by 2 electrons, right? So from 7, we removed 2, it means that we are left with 5. So again, here we can fill 2. After filling 2, it means that we are having 4 electrons filled out. We are left with only 3 electrons from 7, right? So what happens now is that we go to what we call the 2p orbital, which the 2p orbital, they're filled by 6 electrons. But those p orbitals, there are 3 orbitals that can be filled, right? So it means that we're having the first, the second, and the third, right? So what happens is this: when we are filling this, we fill them one by one. We don't fill all 2 in the first and then 1 and then, no, that's not how we do it. So it means that first we fill 1, we fill 1, we fill 1, and when they're excess, we'll come back and start to fill 1, 1, 1 again, right? So we are left with 3 electrons now from 7. So it means that we're just gonna come and say 1, 1, 1, right? So it means that this now it is the diagram, the about diagram of what? Of nitrogen, right? So as I said, the wonders of chemistry. If you look at this, we're having 2 energy levels: energy number 1, energy level 1, and energy level number 2, right? So if we look at nitrogen, where is it? This is where nitrogen is. It is in period number 2. As I said, the period tells us how many shells or the energy level that are filled up to, right? And apart from that, now let's look where nitrogen is. Nitrogen is in group 5. So it means that we are expecting to get how many electrons? We're expecting to get 5 electrons in the outermost shell. So this is the outermost shell, shell number 2. And look how many electrons we're having. 1, 2, 3, 4, 5. Amazing, right? So this is about the group, and this is about the period. So period is telling us how many energy levels, and group is telling us how many valency electrons. So 1, 2, 3, 4, 5 valency electrons, right? And then let's try to let's take a look at chlorine, how chlorine is like. So we're having chlorine now. So let's try to fill this chlorine with its energy levels, right? So as I explained that we start off by filling the 1s orbital, right, which gets filled by 2 electrons. So straightforward, we are filling 2 electrons. But how many electrons does chlorine have? It has 17 electrons, right? So it means that we filled out 2 already, so it means that we are left with 15. And we go to the second energy level, which is called the 2s energy level, right? We first fill the s orbital, sorry. So it means that again we are coming to put 2 electrons. So with the s orbital, we don't question, we just put 2 electrons and then we move, right? And then we go to the 2p orbitals, which I explained that this are built up in this way, right? So let's try to fill in. So it means that from 17 we removed 4 electrons, so it means that now we're left with 13 electrons. So first thing first, we fill 1 1. So it means that 1 1 1, right? So now there are 1 2 3 4 5 6 7. So we still have excess of electrons. So now we can come and say, right, so how many electrons have we filled now? We filled 2 4 6 8 10. So now we are left with 7 electrons, right? So when we're left with 7 electrons, it means that we are moving to 3s orbital. So again, we go and fill the 2. So now we're having 2 4 6 8 10 12. We are left with how many? We're left with 5 electrons, right? So it means that we can fill the 3p now. Right? So now filling the 3p now, what do we do now? We first fill 1 1 1. So now we filled the 1 1 1. So from this 12, if I add this, there will be 13, 14, 15. So it means that I'm left with 2 more electrons to fill out. So now I can go and fill like this, like that. So we're only having this that is only alone without another electron. So these things, they need to be 2 electrons in the orbitals for this thing to become what? Balanced, right? So now let's look. We're having 2 4 6 8 10 12 14 16 17, which is giving us the electron number of chlorine, 17, right? So now it is okay. Now let's look at chlorine, where chlorine is, right? This is where our chlorine is. Let's check the period. So it is in period 1, period 2, it is in period 3. And we explained that periods, they give us what? Periods, they give us the outermost energy level. So it means that now it is in period 3, and you can see that this is ending in energy level 3. Can you see that? And now let's look the group that chlorine is in. Chlorine is in group 7. Does it have 7 outermost electrons? Let's see. 1 2 3 4 5 6 7. It is having 7 outermost electrons, right? So you see now what I was explaining, that this is so much interesting, because each and every element, no matter where it is, if you draw this, you see that the last energy level, it is actually the period number. So if we are having an element that ends up in that is in period 4, it means that it should be having how many outermost electrons? I mean, sorry, how many energy levels? It should be having 4. And if you check this now, the last energy level, it gives us the valence electron, right? So this is the outermost shell to give us the valence electron. And again, I said these valence electrons are demonstrated by the group. Chlorine is in group 7. It is having 7 outermost electrons, right? So now I'm going to explain how this work in terms of bonding and so on, right? Okay, so before we go on, I'll explain these terms, these two terms. There's valence electrons. So these are electrons in the outermost energy level. As I explained, they're given by the what? The group number. And then now we're having valency electrons with the Y, right? So explaining valency electrons, it is actually a number of electrons an atom needs that it can need to do what? To be stable, right? So if we're looking at oxygen and chlorine, for example, right? Oxygen is in group 6. It is in group 6. So it means that it is having 6 valence electrons, right? But now, oxygen needs how many electrons for it to be stable? As I said that the stable number is 8 or 2, right? Depending on the elements, right? So they need 8 electrons, right? So for oxygen to have 8 electrons, it needs 2 more electrons to be added on here so that it can have 8 electrons, right? So it means that 2 is the what? Valency electrons of oxygen. Valency electrons of oxygen is 2 because it needs 2 so that it can have 8 electrons at the outermost, right? So let's take a look at chlorine. Chlorine is in group 7, right? Chlorine is in group 7, so it means that its valence electron is 7, right? But how many do we need for this 7 to become 8? So we need only 1 for chlorine to become having 8 electrons. So it means that 1 is our valency electron of chlorine. Do you get the whole picture? So it means that chlorine can only form 1 bond and oxygen can form 2 bonds. So valency electrons are actually the number of bonds an atom can have, right? If we take a look at carbon, right? Carbon is in group 4. So it's in group 4. Carbon is in group 4, right? So it means that our valence electron of carbon is 4. But carbon will need 4 more electrons so that the outermost shell can have 8 electrons. So it means that also 4 is the valency electron of carbon. If you understand that, it means that, or maybe let me just give one more example of this. So let's look at these two metals, sodium and magnesium, right? So if you look at sodium, sodium is in group 1. So it means that it is having how many valence electrons? So it means that this is having 1 valence electron, right? So it is having 1 valence electron, right? So how many electrons does it need? So if you take a look at metals, mostly there are the loose electrons, or there are the let them be kept by a non-metal. That's when we are having this is when we are having the what? The ionic bonds. The ionic bonds are between metals and non-metals. So it means that it can rather lose this electron to what? To a non-metal. So it is having 1 valence electron and also 1 valency, because it can only make only 1 bond, right? And then we'll take a look at magnesium. Magnesium is in group 2, right? So it means that it is having 2 valence electrons, and also it can rather lose these electrons or it can rather give them to a non-metal, meaning that it is also having 2 of the what? Valency electrons, right? 2 of the valency electrons, right? Yes. So now I will explain a bit of the bond types, and then from then we can get straight to the bonding. So yes, So already I've explained what is why atoms or elements bond, or why do they react to start with, right? I explained that elements react so that they can become stable, right? So they react so that it can become stable, right? So that those electrons in the outermost shell, they can obey the what, the octet rule, to have 8 electrons at the outermost, right? That's why we see some of the elements, they cannot stay as single as they are. You can see that in most cases, when we're talking about oxygen, oxygen is given as O2. If you're talking about chlorine, chlorine is given by Cl2 and something like that. So that's how the elements are becoming stable and all that, which I'll get to it in a moment, right? Okay guys, just for the sake of the length of the video, let me end this one here. So it means that the next video I'm starting on bonding. I'll start to explain the bonding, right? Why bondings happen, and how do elements bond, and in which way, right? Yes.